So in this video, we're going to talk about how to determine the zeros of a rational function. So remember, when we talk about functions, you can find the zeros by setting the function equal to 0 and solving for x. Remember that the zeros will tell you the location of the x-intercepts of the function. So if we have the function x squared minus 5x plus 6, you can set it equal to 0 and find the two zeros which occur at x equals 2 and x equals 3. So the function will have x-intercepts at 2, 0 and 3, 0. So you can determine the zeros of a polynomial by factoring the function, setting the function equal to 0, and using the zero product property to determine the zeros. So let's determine where f of x equals x squared plus x minus 12 crosses or touches the x-axis. So we're going to start off by setting this function equal to 0, right? We have 0 equals x squared plus x minus 12. So since a is 1, we're going to go ahead and look at negative 12, and we're going to figure out the factors of negative 12 that will add up to the b term, which is 1. Since 12 is negative, I need a positive and a negative factor. Since b is positive, that's telling me that my bigger factor needs to be positive. So when I write out the factors of 12, I have 1 and 12, 2 and 6, and 3 and 4. So let's make all the smaller factors negative, and when we add them together, we get 11, 4, and then negative 3 and 4 gives us 1. That's exactly what we need, so we're going to have x minus 3 times x plus 4. Well, if two things multiply to equal 0, okay, this is the zero product property. So if a times b equals 0, that means either a equals 0 or b equals 0, right? Think about it. The only way to multiply two things together and get 0 is if one of them equals 0. So I'm going to set each factor equal to 0, and then I'm going to solve for x. So when I do this, I'm going to add 3 to both sides. And when I do that, I get x equals 3. Over here, I'm going to subtract 4 from both sides, which gives me x equals negative 4. So this is telling me that I have x-intercepts at 3, 0 and at negative 4, 0. So now let's determine where f of x equals x squared times 2x plus 3 times x minus 2 crosses or touches the x-axis. So we're going to start off by setting the function equal to 0. So we have x squared times 2x plus 3 times x minus 2. So we're going to set each factor equal to 0. So we have x squared equals 0, 2x plus 3 equals 0, and x minus 2 equals 0. So we're going to solve each of these functions for x. So here we can take the square root of x on both, or the square root on both sides. So that's going to give us x equals 0. Here we subtract 3. And we get 2x equals negative 3. And then we divide both sides by 2, which gives us x equals negative 3 over 2. Here we add 2 to both sides. And when we do that, we get x equals 2. So our x-intercepts are going to be at 0, 0, negative 3 over 2, 0, and at 2, 0. So we have figured out the x-intercepts of this function. So now we're going to extend this idea to rational functions. The zeros of a rational function can also be found by setting the function equal to 0 and solving for x. Zeros will tell you the location of the x-intercepts of the rational function. Note that when we're working with rational functions, not all of them will have zeros. So if we look at this function over here, we can see that x equals negative 1 is a zero of this function. Because if I plug it in, I get negative 1 plus 1 times negative 1 plus 2 over negative 1 plus 3 times negative 1 plus 2. So that is going to be 0 times 1 over 2 times 1. Okay, so that's just going to simplify to 0 over 2, which equals 0. Okay, so because it makes that function equal to 0, x equals negative 1 is a 0 of this function. That also tells me that I'm going to have an x-intercept at negative 1, 0. So when you're identifying zeros of rational functions, always identify wholes before finding zeros, okay? So you may have wondered by looking at this example, like, why didn't I say x equals negative 2? Well, because if you look at this x plus 2, notice that that's a common factor. So I won't have a 0 at that point, right? At x equals negative 2, I'm going to have a whole. So you always want to factor and then identify those common factors before you look for zeros. So when a rational function is factored and simplified, okay, so why do we want to factor our rational functions? The vertical asymptote can be found by setting the denominator equal to 0 and solving for x. Zeros can be found by setting the numerator equal to 0 and solving for x. Okay, so there is a lot of usefulness to factoring these rational functions. So to determine the zeros of rational functions, start off by factoring and simplifying the rational function. Then set the numerator equal to 0 and solve for x. So let's find any zeros in the function f of x that's described here. So remember, we always start off with factoring. Okay, so we have 2x cubed plus x squared minus 3x. So we're going to look for a GCF. Notice the GCF of these three terms is going to be x. So we're going to factor it out. So that means we have 2x cubed over x plus x squared over x minus 3x over x. So when we do this, we have x times, so we have 2, and then x cubed over x simplifies to x squared, plus x squared over x simplifies to x, and then 3x over x, the x's will cancel, and we have minus 3. So now we need to factor this 2x squared plus x minus 3. Well, when I factor that, I'm going to do that a times c, so I'm going to do 2 times negative 3, which is negative 6. So I need two factors of negative 6. Since 6 is negative, I need a positive and a negative factor. My b is positive, right? B is 1, so I'm going to make my bigger factor positive. So I have 1 and 6, and I have 2 and 3. If I make all the smaller factors negative, you can see that negative 2 and 3 is the correct combination that will add to 1. So I'm going to need to factor this by grouping, okay? So remember, I still have that x in front. That was my GCF. But then I'm going to write this as 2x squared minus 2x plus 3x minus 3. And then I'm going to go inside my parentheses, and I'm going to divide these into two groups. So I have 2x squared minus 2x, and then plus 3x minus 3. And then I'm going to look for the GCF of each group. So that x is going to stay out there. And then here I can pull out a 2x. So I have 2x squared over 2x minus 2x over 2x. And then in the second group, I have a GCF of 3, so I'm going to factor that out so that I have 3x over 3 minus 3 over 3. So now let's work on simplifying all of this. So I have 2x times, 2 and 2 cancel, x squared over x is x, minus 2x over 2x is 1, and then I have plus 3 times, 3 and 3 cancel, and we have x minus 3 over 3 will become 1. So now we have that common factor of that x minus 1. So this is going to become x times x minus 1, and then we have what's left, that 2x plus 3. So that is the factored form of the numerator. Now we need to work on factoring that denominator. So we have x squared plus x minus 2. So we need two factors of negative 2. So since 2 is negative, I need a positive and a negative. And the b is going to be 1. Okay, so since 1 is positive, my bigger factor is going to be positive. The only factors of 2 are 2 and 1. And so if I make the bigger positive, that's negative 1 and 2. And that does add up to 1. So the factored form of the denominator is going to be x minus 1 times x plus 2. So now let's rewrite this rational expression in factored form. So we have f of x equals x times, remember we have x minus 1 times 2x plus 3. So then we're going to write it over the denominator, which is x minus 1 times x plus 2. Remember, the reason we factored both the numerator and the denominator is because we need to cancel out our common factors, right? So this x minus 1, we're going to have a hole there. So we're just going to cancel that out. So that leaves us with x times 2x plus 3.
Could you try again?
Over x plus 2. Okay, so now what we need to do is, now that we have this simplified function, we're going to take the numerator and we're going to set it equal to 0. Okay, so that's how you find the zeros. So for rational functions, you're going to take that numerator, x times 2x plus 3, and you're going to set it equal to 0. You may be wondering now, well, why didn't I take all of the function and set it equal to 0? Hey, you can do it that way too. So if I said x times 2x plus 3 over x plus 2 equals 0, the reason I say just set the numerator equal to 0 is because to simplify this, if I multiply both sides by x plus 2, right, we're allowed to do that. If I multiply this by x plus 2 and this by x plus 2, it's just going to cancel itself out, okay? So either way, you're going to end up with x times 2x plus 3 equals 0. So just saying like set the numerator equal to 0 is just kind of like turning it into a shortcut. So now we set each factor equal to 0. And when we do that, we have x equals 0. And then here we're going to subtract 3 from both sides, which gives us 2x equals negative 3. Then we divide by 2. So we have x equals negative 3 over 2. Okay, so our x-intercepts are going to be at 0, 0, and at negative 3 over 2, 0. So we have now determined the x-intercepts of this rational function, right, by finding the zeros. So now let's find any zeros in this function. So we have this, it's already been factored for us. So remember, the next step would be to cancel our common factors, right? Common factors, we have wholes. So I'm going to cancel out that x plus 1. So that leaves me with f of x equals negative 2 times x plus 2 over x minus 2. So all I do now is I take that numerator, that 2 times x plus 2, and I'm going to set it equal to 0. So I can start off by dividing both sides by negative 2. That gives me x plus 2 equals 0 divided by negative 2, which is 0. Now I just subtract 2 from both sides, so I have x equals negative 2. Okay, so that means that the x-intercept of this function is going to be at negative 2, 0. So now let's find any zeros in this function. Remember, you always start off with factoring. So let's factor the numerator, 3x squared minus 9x minus 30. Remember to always first look for a GCF. Notice that these three terms have a GCF. The GCF is 3. So if I factor that out, I have 3x squared over 3 minus 9x over 3 minus 30 over 3. Okay, so if I simplify that, I have 3 times 3 and 3 cancel, so I have x squared minus 3x and then minus 30 over 3, which is 10. So now I'm going to factor this part on the inside, so I have negative 10, need a positive factor and a negative factor. Since b is negative, I'm going to make my bigger factor negative. Okay, so I have 1 and 10 and 2 and 5. Bigger factor needs to be negative. 1 and negative 10 is negative 9, so that won't work. 2 and negative 5 is negative 3, so those are going to be my factors. Okay, so the factored form is going to be 3 times x plus 2 times x minus 5. Now let's factor the denominator. We have x cubed minus 4x. The GCF is going to be x. Okay, so we're going to go ahead and factor that out. So we have x cubed over x minus 4x over x. So when we go ahead and simplify this, we have x times x cubed over x is x squared minus 4, and then the x and x cancel. So that 4, notice that that 4 can be x squared minus 2 squared, right? It's the difference of two squares. So I'm going to write this as x times x plus 2 times x minus 2. So now let's rewrite this function with the factored form of the numerator and the denominator. Okay, so here's the numerator. So we have f of x equals 3 times x plus 2 times x minus 5 over the denominator, which is x times x plus 2 times x minus 2. So remember, now we're going to cancel our common factors. Okay, so x plus 2 is going to cancel. And we're going to write the function that remains, 3 times x minus 5 over x times x minus 2. Okay, so that's f of x. So now we're going to take that numerator, that 3 times x minus 5, and we're going to set it equal to 0. Well, we can start off by dividing both sides by 3. And so we have x minus 5 equals 0. And then we can add 5 to both sides. So when we add 5 to both sides, we end up with x equals 5. So that means we have an x-intercept at 5, 0. So now you can go ahead and pause the video and try this example on your own. So remember, always start off by factoring the numerator and denominator. So when we factor the numerator, we get x minus 2 times 2x plus 1. When we factor the denominator, we have a GCF, so we get 2 times x minus 2. So when we write the fully factored form of the function, which is here, we get 2x plus 1 times x minus 2 over 2 times x minus 2. The common factor of x minus 2 will cancel. So we're going to take that numerator, that 2x plus 1, and we're going to set it equal to 0. When we set it equal to 0, we solve and we get x equals negative 1/2. So that means that this function will have an x-intercept at negative 1/2, 0.